The National Electrical Code, or NEC, does not contain a specific requirement dictating the number of risers or steps that necessitate the installation of three-way switches at both ends of a staircase. Therefore, if a question on an electrical exam presents a choice of a specific number of risers, like 3, 4, 5, or 6, that trigger a mandatory three-way switch installation, the answer is technically none of the above, or that the code does not specify. The decision to install three-way switches, which allow a light to be controlled from two different locations, is based primarily on practical considerations and user convenience rather than a strict numerical threshold defined in the NEC. Factors influencing the decision to install three-way switches on staircases firstly includes the length of the staircase. For longer staircases, especially those spanning multiple floors, having a switch at both the top and bottom of the stairs greatly enhances convenience and safety. It eliminates the need to walk in darkness, reducing the risk of accidents. Secondly, the number of floors connected by the staircase is also important. In multi-story buildings, three-way switches are almost always preferred for staircases to provide lighting control on each floor level. Thirdly, the intended use and traffic patterns of the staircase are important. Staircases used frequently, such as those in main living areas or commercial buildings, benefit significantly from three-way switches. This ensures that the lights can be easily turned on or off regardless of which end of the staircase a person is at. Fourthly, accessibility consideration should be taken into account. For individuals with mobility issues or visual impairments, having switches at both ends of the staircase can greatly improve accessibility and safety. It allows them to control the lighting without having to navigate the stairs in the dark. Fifthly, the overall convenience and user preference plays a role. Even if a staircase is relatively short, some homeowners or building managers may still opt for three-way switches to provide maximum convenience and control. Sixthly, local building codes or regulations sometimes include specific requirements for lighting in stairwells, including the use of three-way switches. It is important to check with local authorities to determine if there are any such requirements in your area. The NEC provides general guidelines for electrical installations, but it does not delve into the specifics of when and where three-way switches are absolutely required based on a number of steps. The NEC focuses on safety and proper wiring methods, leaving the decision about the placement of convenience features like three-way switches to the discretion of the designer, installer, or building owner. To understand the relevant NEC guidelines, firstly, consider Article 210, which covers branch circuits. This article provides requirements for the types of circuits that can supply lighting outlets, including the ampacity of the conductors and the overcurrent protection required. Secondly, review Article 404, which deals with switches. This article covers the installation and use of switches, including three-way switches. It specifies requirements for wiring, grounding, and enclosure of switches. Thirdly, refer to Article 300, which provides general wiring methods. This article covers the proper methods for installing conductors and cables, including requirements for support, protection, and routing. Fourthly, study Articles 700, 701, and 702. These articles address emergency, legally required, and optional standby systems. These systems often include lighting circuits that must be operational during power outages, and three-way switches may be used in these circuits to provide multiple control points. While the NEC doesn't mandate three-way switches based on riser count, it does provide guidelines for the safe and proper installation of these switches. This includes ensuring that the wiring is done correctly, that the switches are properly grounded, and that the circuit is protected by an appropriate overcurrent device. In typical residential wiring for three-way switches, you'll find these key components. Firstly, a power source, which is the 120 volts alternating current supply that feeds the lighting circuit. Secondly, there are two three-way switches, each with a common terminal, and two traveler terminals. Thirdly, there are traveler wires. These wires connect the traveler terminals of the two three-way switches. They allow the current to be switched between the two switches. Fourthly is the switched leg. This wire connects the common terminal of one of the three-way switches to the light fixture. Fifthly, the neutral wire, which provides the return path for the current from the light fixture back to the power source. Sixthly, the ground wire, which provides a safety path for fault current to return to the source, protecting against electrical shock. The NEC specifies how these components must be wired and protected. The NEC mandates that all wiring must be done in accordance with approved methods, using appropriate conductors and cables. The NEC requires that all metal parts of the electrical system, including switch boxes and light fixtures, must be properly grounded to provide a path for fault current to return to the source. This helps to prevent electrical shock. The NEC requires that all lighting circuits must be protected by an overcurrent device, such as a circuit breaker or fuse, to prevent overloads and short circuits. The size of the overcurrent device must be appropriate for the ampacity of the circuit conductors. The NEC requires that all electrical work must be performed in a neat and workmanlike manner. This includes properly supporting and securing conductors and cables, making connections in approved enclosures, and labeling circuits and equipment. When installing three-way switches, it's important to consider several practical factors. Firstly is the layout of the staircase. The switches should be located in convenient locations at the top and bottom of the stairs, where they can be easily reached. Secondly, the type of lighting fixture being used should be considered. The switches must be rated for the type of lighting fixture being used, such as incandescent, fluorescent, or LED. Thirdly, the local building codes and regulations must be followed. Some jurisdictions may have specific requirements for lighting in stairwells, including the use of three-way switches. Fourthly, future maintenance considerations should be addressed. The switches should be installed in a way that allows for easy access for future maintenance and repairs. Here's how a three-way switch circuit works. One of the three-way switches receives power from the source on its common terminal. When that switch is in one position, power is sent down one of the traveler wires to the other three-way switch. If the second switch is in a position that connects the traveler wire to its common terminal, the light is turned on. If the second switch is in the opposite position, the circuit is broken and the light is turned off. When either switch is flipped, it changes the path of the current, either turning the light on or off. This allows the light to be controlled from either location. In summary, while the NEC does not provide a specific number of risers that trigger a three-way switch requirement, the decision to install these switches is based on practical considerations such as staircase length, number of floors, user convenience, and local codes. The NEC focuses on ensuring the safe and proper installation of electrical components, including switches and wiring, to protect against hazards such as electrical shock and fire. When preparing for electrical exams, it is important to have a thorough understanding of the NEC and its requirement. However, it is also important to understand the practical aspects of electrical installations, such as the factors that influence the decision to install three-way switches.